Um, Hello, everyone. Let me just go back to this. I cannot see the chat and the screens at the same time, so let me just put this in full screen mode. So, hi, everyone. Thanks for coming to this workshop. Um, so, Anil and myself will be presenting to you how to build your own module with the Cosmos SDK. The only difference with this workshop is that we will be presenting with the newest Stargate edition of the Cosmos SDK. So yeah, we'll explain what is Stargate and what's new in it and why you should build with it. So just a quick presentation. My name is Amori here. Amori at Regen.network is my email. I've been in the blockchain space for like around 3 years. I recently joined Regen Network, and I've been working the past couple of months on this Stargate edition and to release this new version of the Cosmos SDK. I'll give the introduction to Anil, who will present himself.
Hello everyone, I am Anil, CTO at Bitbit. I've been into this blockchain ecosystem from last 3 to 4 years. I've been around Cosmos SDK and then developing tools around it from last 2 years and helping other teams to build their blockchain applications around Cosmos SDK. And we are working with Regen Network from last 1.5 years. And yeah, it's been a great journey. So yeah, Amari, do you want to share the screen?
Yeah. So you can see my screen, right?
Yes.
All right.
Okay.
Yeah.
Today we'll be building a custom module on Stargate edition of Cosmos SDK. A disclaimer: the software we're going to use is untested and is highly experimental. The road might be bumpy, so we can expect you might face some breaking changes, breaking things in your hackathon. So be sure about using this software in your hackathon. Okay, next screen. Okay, so why Stargate? So what's so special about it? I think you might have seen a few blog posts around it, and then tweets flowing up about Stargate release. So everyone are super excited about this. So why? Stargate is one of the biggest releases of Cosmos SDK so far. So with this release, so all the features that were mentioned in the white paper are near complete, and it is coming up with a lot of cool features and improvements. And so yeah, protocol buffers is one of them. So protocol buffers are a way of encoding the structured data in an efficient and extensible format. And protocol buffers are language independent, so and platform independent too. So you can just write proto definitions in a proto file and then generate whichever the language, generate the code for whichever the language you're going to use. Like Cosmos SDK is built in Golang, and if you are building your client applications in JavaScript or Rust or any other language, you can just take this proto definition and then use proto compiler of your proto code generator of your favorite programming language, and then generate code using that without worrying about all the internals of Cosmos SDK. So and Protobuf allows us a way for backwards compatibility, so we can extend a proto message without breaking changes. So without any breaking changes, so it uses tags for field numbers. So you can just add any new fields without breaking existing stuff. And it generates, since we have code generators, we'll have beautiful schema and then less boilerplate code. So that's an advantage with the protobufs. And Cosmos SDK is using this protobuf for state encoding and TX signing. That means, performance boost, expecting around 100x performance improvement with this Protobuf migration. So that's really nice. And one another feature that Stargate bringing us is IBC. Inter-blockchain communication protocol is one of the most awaiting and exciting features of Cosmos SDK since the white paper. In simple terms, so IBC enables us a way to transfer tokens from one chain to another chain. Not only tokens, it can be any other ports as well. Like you can exchange assets, and you can have cross-chain smart contracts, and there are a lot of advantages with this. So this means that you can just transfer your Ethereum tokens from Ethereum network to Cosmos network, and then use it here for any payments or anything that you wish to do. And that's how IBC is making a chain interoperable, and we will have a network of inter blockchains with this. And yeah, there are other a lot of improvements on Tendermint side as well. So our Tendermint client is more secure and stable now. Is ready for 1.0, and we have Cosmovisor, an upgrade manager. So previously we used to have manual upgrades. So whenever there is upgrade planned, we used to do the upgrades manually. So Cosmovisor enables a way to do these upgrades automatically and less manual errors. And uh, we have fast sync enabled now. So previously, if any new validator wants to join in this network, it used to take few days to sync entire chain and then start a validator. With this fast sync option, now it takes a few minutes, and then you can start your validator in few minutes. So Stargate is making the Cosmos SDK faster, more faster, and secure network ever. And then, yeah, then a little change we have on binary side as well. So previously we used to have two binaries for any Cosmos based chain. One is a daemon, which was server, and then a CLI for interacting with the chain. So it used to take 40 MB each for these binaries, and then now they got merged into single binary. So we'll have only a daemon, and then all the size also the overall size is reduced to 50 MB now. Yeah, this is more of a user experience improvement. And yes, and then today's go to next slide.
Yeah.
Yeah, our focus today will be, majorly on protobufs and single binary. We'll use protobuf for building our blog application, and then we'll use single binary for interacting with the chain. And Amari will walk us through the blog app, and then followed by a live coding session. Yeah,
Yeah.
over to you, Amari.
Cool. Thanks. Yeah. So that's what I'm going to explain. What we're going to build today. Yeah. So just one thing, Anil, if like I cannot see the chat, so if there's something going on, just like say something to me so that I can
Yep.
I can answer the questions or anything. Cool. So what we're building today is a blog module. I know initially in the description we put that we were going to build a Nameservice module, but the end, Anil and me decided that it was going to take perhaps more than 2 hours to build a Nameservice module live, because there's a more complex logic going on. So I thought like a blog could be much simpler, and like everybody knows how blogs looks with posts and comments. So I believe that this would be a better suit for this tutorial, for this 2-hour workshop today. Yeah, so let's see. So as you may know, Cosmos SDK is composed of a lot of small modules. There's one for bank, there's one for accounts, there's one for staking, slashing, and a lot of other things. So the idea of a Cosmos SDK based blockchain is that you would compose these small modules together and build the logic of your blockchain like this. So today we are going to build our Xblock module, which will use a bit of other modules for the blockchain. But the specificities of our block modules are here. So first of all, the models, the models as in the M in MVC, this model. So we'll have only two models: a post, which is a blog post, which has an ID, a creator, the author, a title, and a body, and a comment, which has a unique ID, also the author, the body, and the post to which this comment attaches to. And these models will be defined by Protobuf, since that's one of our big focuses today. So once we have our models, we'll define the messages, which is actually really just the state transitions. If you imagine the Cosmos SDK as building a state machine, then messages are state transitions. So so in the Cosmos SDK, they are called messages. We'll create also two, just to keep stuff really simple, we'll create one message to create a post and another to create a comment. We won't deal with, deleting or updating stuff. I think once you get the gist of how to create and how, of one message, you know how to write the other messages by yourself. Again, these messages will be written in Protobuf, and we'll see what that means and how it works. After that, our blog module will have queries. Queries are what we call in the SDK just the fact of querying the state to, if you imagine the Cosmos SDK app as a state machine, then queries are just to know the current state of the machine or the state at a certain block height. So again, make it simple here. One to list all the posts and another to list all the comments of a post. And these two will be written with Protobuf. We'll see how that works. And finally, the module has a keeper, aka the business logic. So when does a message go in the state, or when is it invalid or not? This keeper logic is written in Go, and we'll write a bit of logic related to that. I hope the blog module is simple enough so that you can follow along and code with me, and that you can follow my live coding when I write this. So let's get to it then. So the table of contents of how to build this blog module will be divided into 3 steps. The first one is just a simple step to set up the boilerplate. You can use this git clone, this repository that's linked here to git clone already the boilerplate basically. So step 1 will be just cloning this repository and making sure that everything runs, and have a skeleton to write our blog module and to write the whole blockchain. The step 2 will be actually to write the module and to configure it as I have defined in the previous slide, with the models, the state transitions, and the queries. And step 3 will be a kind of a live demo of what we built. We'll run the node, we'll make some transactions over the node, and we'll interact with our X module, our X blog module to see if the transaction and the state is working well. So so follow and code along. I think it won't be so complicated to git clone and to code at the same time as me. If you don't want to code, then no problem at all. You can also just follow the slides and my live coding. So let's see. Set up the blockchain. Step 1. So step 1, I will clone. Well, actually, I will switch to my terminal, which is here. Probably I'll put in big screen. Here it is. Bigger. All right. So so I basically cloned the repo. Cool. Well, let me see if I have it saved here. No. Anyways, I cloned this repo. like just for you to know, I'll probably paste it here on the chat so that everyone can just clone without actually writing on their, like copying from the screen. So I cloned this repo. There's like step 1, step 2, a README, like a small README to how to do it. I'll basically go through this README, but orally and on my terminal. So that's what I'm going to do now. So if I ls this repository is exactly the README, the license is step 1, step 2. So that's what you'll get when you clone the repo. If you're coding along, you should have this step by now already. So what I'll do, to be honest, like step 1 is basically the boilerplate, which I won't write because it's really just plumbing code and not super interesting. What I'll do, I'll just copy step 1, the folder, the boilerplate, and name it blog. So blog is our folder. So if I go to blog, I'll see all this stuff inside that's boilerplate code, and I will use my editor to go inside this folder. Yeah, so it's here blog. But instead of having this, I think my editor doesn't recognize when I have multiple Go modules in the same folder. So I'll go directly in the blog folder over here. Cool. Right now I'm in the blog folder. So like I copied the folder right from step 1 to blog. So if I like look for step 1, there's a lot of step 1 stuff. What I want to do is really just rename them to blog, so that we only have the blog instance and it's not called step 1, and everything should be prettier once it's called blog instead of step 1. There's also, I think, in this command, a folder called step 1. Yeah. So instead of step 1d, the daemon, the CLI daemon, I'll call it blog d so that it's a bit prettier. All right, so cool. Once I've done this, rename every step 1 to blog. I have a tons of file changes. That's normal. I'll just commit just to make the future changes a bit clearer. Step 1, rename to blog. Cool. And what I wanted to make sure in my presentation, if I can find it, yeah, it's here. Yeah, see into step 1, but I didn't do that. I went into blog and go build just to make sure that everything built. So am I in blog? Yes, I'm in the blog. So go build. I'll put the output binary in the build folder, and let's see if it builds. Cannot build multiple packages to a non, like that. Yeah. cd blog. Wait, is it the Go mod? Here it's okay. Okay, that starts good when we're live coding. All right, multiple packages to all right, to non-directory. Make your build. All right, cool, now it's building. Oh yeah, this is just some warnings on building Go with on my Mac OS. Let's wait a bit to see if there's nothing, no build errors, no compile errors. Cool. I think everything's fine. So if I go into my build folder, I should see blog. So if I run the blog b, I should see I'm just running the binary that just got built. Yeah, so you'll see a bunch of comments that's part of the boilerplate. Cool. So so just before going, I think the next slide will be step 1. Sorry, step 1 builded modules we'll use. That's the step I wanted to go into. So to show you a bit the modules, how they're defined, and what this boilerplate means. So like this boilerplate, if you clone it, you have exactly this folder structure, but it's actually built using a tool called Starport. Starport is like kind of a scaffolding boilerplate generation tool for Cosmos SDK. The thing about Starport is that it's still in alpha version in regards to Stargate. It means that it's still using the 0.039 version of the Cosmos SDK. And the 040, it's not being really updated to 040. There is some updates, still experimental. That's why I didn't want to actually propose to you to use it here, because yeah, you might run into bugs that I ran into the past couple of days. Wanted to avoid that, so I preferred for you to just clone this repo and run it. So when you run Starport builds and fix the bugs, then you have this kind of structure where you have a Go module with all the dependencies that you have, and some folders here. So the main folder the main folder, to be honest, for us that will concern us is the x/blog folder. This is our modules. There's a convention in the Cosmos SDK to put all the modules under the x/module name. In the Cosmos SDK official repo, it's also like this. Yeah, so that's where people keep their modules, and in the modules, that's what we're gonna modify in the next couple of minutes. But just to go through other modules, the important one also is Proto. So Proto is also a convention we have here in the Cosmos SDK to put all the Proto files. So yeah, so for the Proto files of our blog module, it's gonna be in blog v1 beta, and then we'll have a bunch of Proto files inside. And we also have some Proto files from the Cosmos. These are really copy pasted from the Cosmos, and that's only because our blog needs to have a reference to these files. So that's why we have like one Proto from the Cosmos and some other Proto files from Google, Tendermint, Cosmos Proto. It's also something we're maintaining from the Google Proto library. I'll explain a bit what that is, and also from Confire. Basically, all third-party Proto files that our blog's Proto file might need. We need to actually put them all together inside one, inside our repositories for them to be referenced. And we have this script that's in scripts that's called protocgen. And this script will just basically look into all the Proto files into the correct folders, like the third party and the Proto file. We'll just look into all these folders, look for Proto files, and compile generate the code that's interesting for us. Yeah, so we went through Xblocks, third party scripts, Proto. Internal are just some tools. There's really not for us, it won't concern us today because yeah, we won't have any tools, but we could have. So there's the CMD command/blockd. This is the command line interface. Yeah, so blockd is the name of if you remember, I built my binary in the build folder, right? So blockd is exactly like where you define your binary. It has a main.go, which is the entry point for any Go binary, and then inside it has some configuration. Again, mainly it's boilerplate code to add a Genesis account that's kind of always needed, and instead of copy pasting your own code like here, you just use the scaffolding tool which will do that, and some routes which will actually wire up all the command lines from other modules. And finally, the last folder we're gonna look into is the app folder, and this is the core of the code, of the boilerplate code. It's the app. So the app is basically your blockchain app, the state machine, where the state machine is defined. Our app is called blog app. It has some default node home, like the home folder, and all the modules that we're gonna use. And I think before going into too much details into this code, I'll just show a quick overview of the modules that we'll be using in that big file. Yeah, so I mentioned already auth for accounts, bank for tokens and balances. I think this is the basic module for all blockchains. I have a hard time imagining blockchains without these two modules. But yeah, so the next ones will be staking, distribution, and slashing. These three often go together for POS chains. Staking is really for validators and who's in the validator, how to decide who's gonna be in the validator set. Distribution is for delegation, so for people that are staked, that have the tokens of the chain but don't want to be a validator and can delegate their tokens to these validators. And slashing is a module to incentivize people validators to be malicious on the network, so that when they have a bad behavior, they get slashed, aka their tokens get decreased. We're using some more modules related to minting, to upgrading chains, to a bunch of other stuff that, to be honest, I don't think it's worth going on today in this workshop. So I'll pass that. And of course, there's our own blog module that we're building and that we'll build in the next section. And there's some modules that we won't use, namely the IBC one, as Anil has said in the first chapter. We won't actually use IBC today to keep it really simple. Cool. And how do you define the modules inside here? So you import the relevant modules from github.com/cosmos SDK/xof/xbank/crisis distribution, all the modules, and you define your module basic manager, etc., etc. So this is really like all boilerplate code, and I don't think it's really interesting to go through like this 500 lines of code. But just to know that this is the place where you would choose the modules that you would want to add in your chain, and and configure them so that they're correctly wired up. In particular, our blog module skipper is gonna also be defined here. I won't go much more into details. One thing I will want to add is about the codec that's being used. So the codec is basically the piece of software that we're using to encode and decode stuff, so to serialize and deserialize stuff. As we said, the big innovation in this Cosmos SDK 040 is Protobuf. So we are using Protobuf codec here. So when we define here app codec, it's actually we're going to put in Protobuf codec as app codec. The reason why this one right now, it's an interface here, if you see this codec.marshmallow, it's an interface, is because we're also supporting Amino, the legacy Amino codec. And that's why we want people to be able to use Amino or Protobuf. Our rationale was that Protobuf might be too big a change for once, so that people could still use the old Amino legacy codec for their chains without switching all at once to Protobuf, while still having other benefits of 040 like IBC or some other stuff. So that's why this this app codec is an interface which is either Proto or Amino. And where we define that it's Proto, it's actually in encoding here. So params that make, it's actually in this one, params encoding, proto.go. We define that make encoding config, that's the function that was called before. And the marshmallow that we called is a new proto codec. So that's where we define that our app is going to use Protobuf for states, for storing stuff in states, and for TX signing. Cool. I think that's it for this first step concerning the boilerplate code. So let me see if I have some more slides going on here. Nope. Yeah. So let's go into step 2, which is create our own XBlock module. Cool. Important bits of a module. What are the important bits of a module? I kind of explained a bit before with the models, the state transitions, and the querying the state stuff. Let's start with the Protobuf definition. Protobuf definitions basically allows a module to define the public interface of the module, so that any client, just by looking at these proto definitions, will know how to interact with the module. As we said before, we're defining the model, the messages, how to query the module. All these are defined in Protobuf, so that a client in JavaScript or in Rust or any other language can just look at these Protobuf definitions and know how to send a transaction or query the state of this module. I know I've been talking a lot about Protobuf, and I know that it's possible that some of you don't know what Protobuf is exactly. So I prepared here a little slide to just quickly explain in 5 minutes, just for people who are not aware what Protobuf is, who are totally new to Protobuf. Protobuf is short for protocol buffers, and is a piece of software that was created by Google a couple of years ago. And this software actually does encoding and decoding. So basically serialization and encoding library. The good thing about Protobuf is that it's language agnostic and platform agnostic. And it's quite performant also in terms of size that's transmitted over the wire. Um, and also another big reason why we chose Protobuf in the Cosmos SDK was that it's battle tested and very easy for client libraries to implement. Yeah, we were coming before in 039. The encoding library was Amino, which was a custom custom encoding library similar to Protobuf 2, but with some differences. And these differences made client development quite hard. There weren't actually many really solid client libraries you doing amino encoding, and this like kind of stopped, or maybe not stopped, but like decreased the velocity of client side library development. So that's why in 040 we decided to introduce Protobuf. Yeah, so that basically we have a battle-tested, efficient, very platform agnostic and language agnostic library for encoding. So how does it work? Protobuf works in basically writing your models or your objects, your structures, your types inside the proto definition files, which looks like here in this message post. So message would be the equivalent of a struct in Golang, or a class in TypeScript, or a struct in Rust, for example. So you write basically this message post in a proto file. Let's say our blog post has a title and a body of both of type string. The fact that we're putting =1 =2 here is really a Protobuf spec kind of thing, where like when Protobuf encodes and decodes, it knows that the first the field with number with ID 1 is title, and the field with ID 2 is body. So this is really a Protobuf detail. But yeah, generally you just go from 1, 2 to 3, 4, 5, as much fields as you need, and you increment the field numbers. So this is really at its simplest what a Protobuf definition looks like. So with Protobuf, as I said, it's language agnostic. And the reason why this happens, it's because this same message here, this proto definition, gets converted or gets generated into the actual language that you're typing in. So for example, if you're here on the left side, if you're building a client-side library, this message post, when you run the script that I show you, that I will show you again, but just to remind you, is this proto cgen to generate the generated code in the language. If you run this code, this message gets transformed into a class in TypeScript. Like let's say your client-side library is in TypeScript. So it's going to be a class with title and body. And at the same time, on the Cosmos SDK, we generate into Golang. So it will be a struct here with title and body. The idea is that this same message gets generated into any number of language that you want. So that eases a lot client-side development for libraries in any language. So that's the first step. So and then second step, let's say you have a node and a dApp, and this dApp which uses the TypeScript client-side library wants to send a post with title, some title, and body, some body. So Protobuf would then marshal this class into an array of bytes if we're using the binary encoding. So here it's really like I'm just putting here random string or random array of bytes. So this is the proto encoding of the post that we just created. And then on the node side, on the Cosmos SDK blockchain side, the blockchain will receive this string, this byte array, and will unmarshal this byte array into the post struct that's corresponding to the same proto message. And that's what we'll write basically in our we'll use in our xblog module. I hope that's it. If you have questions, you can ask those questions on the chat and I'll try to answer them after. Yeah, let's go on with the important bits of the module. So protobuf definitions is like the first important bit. And then there are other parts which are the handler first. So handler is how to handle messages. As we said, message is the way we call state transitions in the Cosmos SDK. So you have one handler per message. If it's a create post message, then we'll have a handler for create post. Keeper is what we call the core logic of each each module. Each module has its own keeper, and yeah, the keeper will decide if, for example, if like a message is correctly formed, if it goes into state, or if I return an error in that case. And also it has a reference to the store and writes to the store, so to the state when actually it needs to write, if, for example, if a message is correct. Keeper also implements the gRPC query service. We'll see what this means a bit later, I guess. But like just to have a big idea, it's like to query the states. As I said before, one part of the Xblog module is to be able to query the post and the comments of a post. So that will use gRPC to do that. We could also use the legacy query, and that was the way it was done before the introduction of Protobuf and of gRPC, was to use the legacy query, which we'll also have a look how it works. So just for you to know that the legacy query is, it's still here right now, not to break too much backwards compatibility, but it will be removed in a future release of the Cosmos SDK. So yeah, these three parts I would say are the most important parts: protobuf, handler, and keeper. There are secondary, yeah, I would say optional, but still very useful parts of a module would be the client side of a module, so the CLI, how to interact with the module via CLI, or how to interact with the module via REST. Yeah, since there's gRPC, to be honest, it's like, I wouldn't say it's super required, but we'll still see how it works. Because right now, the client-side libraries are still not yet super mature, so CLI and REST might still be the best and easiest way as of today to interact with your node. And finally, there's going to be a module.go, which is plumbing and wiring up all the different pieces, and yeah, so that they go inside the the app.go file that we saw at the beginning in the boilerplate. Cool. What's that? Step 3? Yeah, no. So step 2, let's go into live coding right now then. All right. So here, if you remember, I have my blog folder with Xblog module. Like if you see, just to quickly have a look, client was CLI and REST. What I just explained, keeper had the gRPC, the keeper, the actual logic, and the legacy query. Types are just like, all the types that we need for our blog module, and then Genesis to define the Genesis state if there is. We won't touch that a lot. Handler to handle all the messages, and module.go was the plumbing type, plumbing file to wire everything up together. So as I said, like the first thing would be to go into yeah, the proto files. That would be the first step. So again, I won't write everything, and I will try to use the Starport tool so that yeah, so that it's much faster and easier for you to follow. So Starport, as I said, was a tool for scaffolding stuff, scaffolding Cosmos SDK blockchain apps. To add a type, there's a command called Starport type, generate CRUD actions for type. Well, our type is a post first, and it has, as we said, a title and a body. Cool. It says exit 1, status 1, that it didn't work, but yeah, that's again because it's not super well fitted to Stargate yet. So, but it actually generated some stuff that we'll have a look later, and also create another model called the comment model, which has a body and a post ID. So as you remember, that was yeah, our simple block with post and comments on the post. So let's see what it generated. Yeah, the good thing is that it's all in green and yellow, the generated stuff. So for a post, it generated a message post, which is the message that we'll use with an ID, creator, title, and body. By default, it output as string, which is perfect for us. To be honest, I really don't like how Starport generates its files. I prefer to put all these files into a tx.proto. So I'll do that. So that, and this I'll call query.proto. So that we have one Genesis proto for Genesis state, which won't touch, one query.proto for all queries, and one tx.proto for transactions. So message post and this one, so I'll import it here. All right, cool. And then this and this we don't need anymore. And cool. Well, instead of v1 beta, we could even put v1, so it's blog v1, blog.v1. Yeah, I'm just cleaning up some stuff so that it looks better. Cool, this blog.v1, this blog.v1. Okay. And I think here, instead of importing comment, we need to import, all the v1 beta one needs to be written into v1. Oh wait, no, not these ones, because these are from Cosmos. And import from tx. Cool. Right, so let's go a bit through these proto files. I'll skip Genesis again. Let's start with tx. So these are the two messages that we'll have. The easy part about this workshop is that the tx, the message, so the tx message and the actual model will be the same, because in both cases we'll create one, a tx with an ID creator, body, post ID, and here title and body. And then, so these are the messages that we define into in Protobuf definition. And then here are the queries. So in Protobuf, the way we define queries are with gRPC services. There's a special service. There's a special keyword service in Protobuf, which defines services, which are basically RPC endpoints. So you define your RPC endpoints in Protobuf. Here we have two endpoints, one called all comment, one called all post, to return all the posts and all the comments. And each time there's only a pagination here in the request, and for the response we have the comments or the posts. So what I will add to actually is in the, when we want to query the comments, we also actually want to put the post ID, so that we can query all the comments that are for a certain post ID. Cool. So again, so two simple RPC endpoints, and that's how we define the proto definitions. And that's it for the proto definitions. It's not really complicated. There's you just need to get hold of the syntax that Google created for that. But it's quite straightforward, and the next step would be to actually generate the Go code corresponding to these proto definitions. And that's done with the scripts protogen. All right, it's not defined. Cosmos.base.query. Do I need to? Oh yeah, okay, I got it. The v1 beta 1 was in my, all right, cool. So now it generated and no errors. And let's see what did it generate. When it generates, where it generates is defined by this Go package option. Just a quick note that we're using a library called GoGoProto, which is a fork of the official Go implementation of Protobuf. We use this fork because it allows for a bunch of small functionalities that are really cool. But it doesn't really matter in absolute. It doesn't matter which implementation you use. But some options like that are specific to GoGoProto. And here it created this pb.go file. pb.go stands for protobuf.go, and these are code generated by product gen gogo, which is the GoGoProto implementation we're using. All these pb.go are generated. So the query.pb it's not needed. It was in the query.proto that I had here before. Since I deleted and I renamed query to query.proto, that's the query.proto that we're using. And that's just like, this is generated, so it's like, very hard to digest. But I just want to have a look at the message comments and the message post struct and see how they're generated inside the generated code. So I'll look for message post, and you see that the generated message post is actually a struct, a Go struct with ID, creator, title, and body. So creator is quite interesting because if we have a look at the creator inside our message post, the creator, it's bytes. So so over the wire, it's going to be bytes who are going to be sent. But here we use this Google Proto, one of the Google Proto extensions that I find useful. It's basically to cast the bytes into a account address type that we have defined in the SDK to manage accounts more easily. So, and yeah, that's what happens. So when you generate, you actually don't have bytes here, but you have this account address, which is actually byte, but we implemented a bunch of other, other functions on it, like to see if it's equal to another address or to do a bunch of stuff. So these are the proto-generated files. Let's see what also got generated in let's start with the handler, because it's one of the simplest, I would say. So handler. So handler, as we said, it takes messages and does state transitions. Let me say that's well indented. So every time we get a new message, we switch the type of the message. If it's a message comment, the one that we define in the Protobuf definition, then we do something, we handle it. If it's in the message post, then we handle something else. And let's see what these handlers look like. These handlers are really simple, and I would suggest to keep it like that so that, it's simple to reason about. So the handler it's just doing a simple thing, which is relaying the content to the keeper. The handler has a keeper as an argument, and the keeper, as we said before, was the core logic of the module. So basically the handler says, all right, whenever I get a message, create comment, I'll just tell the keeper to create a comment. Exactly the same thing here. Every time I have a post, I'll tell the keeper to create a post. Cool, so what does the keeper do then? Let's have a look at create post. So keeper post will will create, like, fetch the store. It's called new store, but it's actually only fetching like the current store. So the store is like, basically the try that's being saved into, at the end, the KV DB. So it takes the store, and where does it save? It saves into some keys. So I think, before I go into the store, I should probably mention the keys. Keys are defined in keys.go, and keys are basically the prefix of the branch in your tree when you want to save some value at some leaf. So in our case, it starts the store key will be block, and then it will be block appended to the post, appended to and that will be the key of where it's stored, and the value will be the value of inside the key value store. So this is like in a high level how it works. Inside the keeper, to be honest, we don't need to know really the details of this. We just would need to go into our post.go, how it's handled. So we'll just take the key, take the store, put it in the correct key with the post key, like whereas the appended would be like, this would be the blog prefix, and then the post prefix. That will be the where we're storing our stuff, and bytes. And then we are going to marshal the post. So the message post that we're having here from Protobuf, we're going to marshal it, so serialize it into bytes. This is of type byte array. And we're serializing using the codec, which, if you remember, codec.marshaller, at the beginning, we defined it as to be the Protobuf codec. It can, as I said before, still be amino, but Protobuf might for sure be simpler. And once we marshal the bytes, we set in the store at that key, we set the value of the bytes. And that's basically creating a store, creating a post inside a store. One note about validation, like, imagine if we didn't want to save a post without any title or without any body. This could be done in the keeper, but there's a more there's an easier way to, or more like more canonical way to do it. It's inside the message post itself. Oh wait, no. So that's the generated one. But if I go to message post, yeah, there's this SDK.message interface that we're using across the SDK to represent the message. So it's basically that message post struct that I showed before, but we add a bunch of methods on it. And one method is validate basic. So validate basic will actually be called even before the message reaches your module in what we call the anti-handlers. So the handlers that are to verify the signature is correct and verify all the messages are well formed. It will run validate basic at that point, so before anything else. And if validate basic doesn't pass, then the message will not even hit the xblock module at all. So yeah, here in the validating basic, we can also say if message.body equals empty string, because body is of type string, return like no sum SDK.err invalid. All right, can be body can be empty. We can define the same thing for the title and like a bunch of other like easy, cheap validation that you can do. So yeah, the important things are cheap validation that this message post cannot, doesn't know about, the state, doesn't know about anything else. It just validates on its own fields. Yeah, and if we wanted really to do some validation that are more complex and need access to the store, need access to other modules, yeah, say like if we wanted to create a post only if it's written by a validator or something like that, we would reference the staking module here, and we would find all the validators from the staking module, list through them, and make sure that the post creator is equals in one of the array of the validators. That's the kind of logic that's the kind of validation that would go inside create post, as opposed to the ones that will go into message create, the message implementation. Yeah, cool. So let's go through get all post, which is the other piece of logic that the keeper implements. Yeah, it's super simple again. So this fetches the store exactly the same store as before, and it creates an iterator. So an iterator is like really just something that goes through all the values, all the key values in the store. Yeah, so for each iterator, we will put in the return value, we will append the one we get. So yeah, we go through all the values inside our tree. Every time we have a value which is which is some bytes, we unmarshal using again Protobuf defining the codec. We unmarshal into this message post type, and then we add it to our array that we're gonna return at the end. So yeah, really simple stuff. Actually, and this is gonna be exactly the same for the comments. So since it's Starport, it's really copy pasted code. One thing like we could do, for example, would be here in create comment, yeah, to loop through all the posts, like in the let's say post ID equals comment.post ID. I wonder why I don't have auto completion here. Whatever, computer is a bit heating up, so probably not working. But yeah, so post ID, okay, at least this is working. Post ID, this is a string. We could take the string and then, yeah, I'll just write a comment, loop through all the posts. If no post has that post ID, then return and whatever. That's also the kind of validation that would go inside the keeper. But I think maybe like not for this workshop, or maybe later if we have some time at the end. But like I think it will be quite straightforward to write this piece of code anyways. So cool. So these are the messages. Like just to summarize very quickly again, it starts from the handler. The handler has some message types, relays that to the handlers. The handler is actually only related to the keeper. and the keeper, for example, the post keeper, I mean the keeper that manages, the part of the keeper that manages post is here, and you can do some validation here too, or if it's not doing validation, then you write to the store directly. That's how handlers work, and with this, you basically have a state machine, because you write to the store every time, and and your state can move on. And at the end, like the app, so yeah, basically the app.go and everything, and the wiring up in the Cosmos SDK will make sure to regroup all these stores together and to generate one state hash for the host state. Cool. So that's it up for handlers. I'll move on right now to gRPC queries, or queries in general. So how to query the states. As I said before, there are two ways to query the states. So the one is via gRPC, which is newly introduced in Stargate in Cosmos 040, and there's the legacy querier. So let's get through the legacy querier first so that it's done. The legacy querier actually uses ADCI. So you basically make a query through the Tendermint query endpoints, and then Tendermint sends a request query, which is this interface or this struct, to the Cosmos SDK, and the Cosmos SDK basically handles this path, this query, and this query has a path. The path is basically the which module you're gonna query. So here our query, like the path here will already start with /blog or blog/ something, and then if it's blog/list comment or blog/list post, then in those two cases we do the list post handler, which is again a super simple handler that will just defer to the keeper to get all posts. One thing that I would like to add about this query before we move on, it's this query doesn't use Protobuf, and that's why it's called legacy. It's one part of the Cosmos SDK that we didn't migrate to Protobuf, and that's because we don't want to break backwards compatibility for clients who are right now using this query endpoint. So that's why this query has a legacy amino codec in arguments, and it's gonna use, if I look here, it's gonna take it's gonna take all the posts from the keeper, and then the codec, which is here, it will use the legacy amino codec to output. So the JSON output will be legacy amino, not to break compatibility. I won't dwell too much on this legacy query, and I'll move on to gRPC, which is the interesting part. So gRPC is an RPC implementation from Google, also that leverages all the positive sides of Protobuf that I talked about, like language agnostic and being super performant and battle tested and a bit everywhere right now. So gRPC is an RPC implementation on top of that. This RPC has some kind of spec, and you define the RPC endpoints, as I said before, inside the service keyword in the query.proto. So we have two RPC endpoints, fetch all comments and fetch all posts. So fetch all post will be here, fetch all comment will be here. Before we go into that, would like to show very quickly the generated code for these queries. So query all, like if I have a look, like I'm looking at this, the first, it will be query all comment request. So that's the request type to query all the comments, has a post ID and some pagination if we have a lot of comments. And that gets translated also into a Go struct. What I'm more interested is the query server, which is this interface. And this interface is the server for our query. So server is maybe like a weird word in this case, but for us, it will be simpler to think this as the keeper. So this is the interface that the keeper needs to implement so that it takes like a Go context, part of it takes a request for all comments and returns a response for the comments. And same thing for a post. And that's basically the interface that our keeper needs to implement. And that's being done in the gRPC query.go. Our keeper implements this query server interface, which is defined from the service inside the proto file. Well, I don't know why Starport put the implementation to 2 different files. I wouldn't do that. I would just put everything here. But yeah, whatever. Let's see the all post, how this looks like. So as we said, all post takes a Go context, a request for all the posts, and a response for all the posts with some pagination. Again, this should be pretty straightforward. If there's no request, we return an error. So we use, this context, Unwrap SDK context. So this is a Go context, but inside the Go context, we actually pack what we call an SDK context. And SDK context is, like an object that has the current height, the gas consumed, a bunch of stuff that are related to that specific query in that specific blockchain. So we take that, we take our store, and so now we paginate. That's basically the only a bit hard part compared to, let's say query a post, which would only return all the posts. In the gRPC, we want to do a bit cleaner, and we want to actually give a paginated result so that we don't fetch everything from the store at once, and we don't return everything from the store. But we kind of paginate, and every time at every callback, we create a closure which would just do the same thing, and marshal the value, which is some bytes we get from the store, and marshal into a message post, append to the posts, and only return these posts which are paginated posts. I guess that's it for the gRPC queries. For the comment, it will be exactly the same. So as we know, the comment has a post ID. This post ID gets also passed into the request, and it will be in the keeper's job, which I actually didn't do here. I don't think I'll have time, or maybe we'll see at the end if it's interesting for you. In the keepers, where we're gonna iterate the iterator, we actually don't want to append everything, but only I'll do it quickly. If message.id equals, let's not get all post, but in the comment, we don't want to append every comment because I will fetch all the comments, but if message.post ID, so what do we have prefixed? Get all comments. Well, probably I need to think a bit more about this instead of writing here. I think it will be too much of a rush. So instead I'll move on to explaining the remaining parts of the module to keep in time. Let's see. So we explained the keeper, we explained the handler, we explained the types, which are just really type definitions inside our module. So the last part of it, well, there's module.go, but this is plumbing. The last part of it is the client side of stuff, which has the CLI and the REST endpoints. Let's start with the REST endpoints. So REST, the REST endpoints are really special in a way that they are also some kind of legacy code, because so the way it works is that if we want to query, as I said, the best way would be to use the gRPC query server. So on the client side, to use a gRPC client and query directly the node, and that query will hit the gRPC query server in the code that we saw before. The reason why we're keeping this REST endpoint is because of legacy reasons. Again, for people not to break compatibility, especially for wallets and exchanges who rely heavily on these REST endpoints to interact with the node. So so these REST endpoints are legacy, but still good to have as long as the gRPC and Protobuf ecosystem inside the Cosmos SDK is not mature enough and developed enough. So yeah, so like pretty simple. Each time you handle a path for the REST endpoint, and for each path you have a handler. So let's go to create all the posts. It will be again to a like client context dot query with data. That's exactly the query of the Tendermint node that I said before. So that query with data performs a query to the Tendermint node, and this query would actually not hit the gRPC query, but the legacy query.go that we define here, which I said was to handle Tendermint queries. So yeah, so legacy endpoint is using legacy query. That should all make sense, and that should have the less friction with new stuff. It'll be the same with commenting. I'll have a look at the TX. Yeah, so this should also be quite simple. We just create a request from what we got from the HTTP request. We create a post request because it's sending with post, and after validating and sanitizing, we'll just create a new message post. This is the interesting part. We create a new message post, and message post will return, the Protobuf struct that we chose, and then we'll write to we'll send this message to actually the app, and again it will go through the handler and the keeper kind of pathway again. Yeah, that's it for the REST endpoint. I just want to mention something very quickly. It's that in the 040 SDK, we also added something called the gRPC gateway. gRPC gateway, yeah, just gRPC gateway. So gRPC gateway is basically a mapping from gRPC to REST. So in the query here, we defined all the gRPC endpoints. So these are the endpoints that are only callable by gRPC. But what we noticed is that, first of all, gRPC only works with HTTP2, so it won't work with HTTP1. And a lot of people are still not using gRPC and prefer to use a simple REST endpoint. So yeah, so instead of having exposing gRPC endpoints, one could also use gRPC gateway to expose REST endpoint. Sorry. So for each gRPC endpoint, there will be an equivalent REST endpoint, and for this you need to add some annotation, which I right now don't have in mind how they look like, but I think it would make sense to just go through very quickly github.com how that look like, because that might be useful if you're building a module. Cosmos SDK, yeah. If you're building a module and you don't want to figure out how to do the gRPC client side of things, you could just write these annotations and Protobuf will generate correctly. So let's take a simple module like bank. Oh wait, the proto files are not in Xbank, but in Proto Cosmos bank v1 beta 1. And like if you see here, that to quickly show, it has exactly the same kind of structure that we had TX query Genesis. This one to have other shared types. Inside the query, we have RPC balance. To query the balance of someone, where balance request for sure has an address. Yeah, here has the address to query the balance for and return some balance. And here, what we add would be to have this option kind of thing. So this is a gRPC gateway option, so that we could, add every time we do a GET request to this blog, or won't even Cosmos because it will be just our /blog. Every time we send an HTTP request to this with a GET method, comments, something like that. Comments, actually post ID, we will need that. Every time we send this request, it will actually, gRPC gateway will transform this REST request into a gRPC request, and the gRPC request will go through the keeper gRPC query kind of path that we explained before. So that's like a shortcut for REST, using REST. So yeah, so like just to let you know that with this annotation, gRPC gateway, I personally don't see the point of actually implementing the REST legacy endpoints, unless it's for backwards compatibility reasons. But yeah, no, I don't see like right now the point. So in the future release, we're actually going to remove these legacy REST endpoints too. Cool. What else? I think we went through REST. All right. So the last part will be the CLI. So the CLI has two main files: one to query, and one to send transactions. So if we want to query, we would add a command with using the Cobra. We're using Cobra for managing CLI, which is a popular Golang library for creating CLI applications. And each time we can add a comment to do something. And here we're adding a comment to list all the comments. Yeah, so here Cobra use list all comments. Well, to be honest, like we would also need like a post ID kind of argument. And yeah, args, we will need like, I think it's Cobra dot, I have, yeah, okay. Cobra dot args. Exact args, I think, yeah, we need one exact arg. And then inside the callback in the args, we would have, yeah, post ID equals arg0 to get the post ID. And then at some point we need to make sure that the post ID is not empty, etc., etc. And yeah, when we do our request, we would have post ID. Yeah, that's how we would add our CLI. So that basically what we're doing is we're reading the arguments from this list comment post ID, creating a client contact. Client contact is really a bit like, you know, SDK related code that you could find interesting, but it's not super important to get into the details. But it's just to create a context which could communicate with the gRPC server. Yeah, so also the comment will have some pagination flags to do the gRPC pagination stuff. And then once we have all these flags, we create a client, and with the gRPC query client, we send a request in this all comment function. And so here again, this is using the query client, which is a gRPC kind of type, and this sends a gRPC request, a query request to then the gRPC server, which again is implemented here in the keepers gRPC query.go files. Yeah, so that's query comment. Query post is even more easy because there's no arguments. Let's go quickly through the TX stuff. Yeah, so TX here, we're also for our module, we're creating create comment transaction endpoint for our CLI. And yeah, this create comment takes a body and a post ID. Again, here are the args, are post body. We could do some simple validation here, but to be honest, not strictly needed because we would already do this validation here in the new message comment. Remember, we had this validate. Oh, it's actually here. Yeah, so it's here, the validation. Yeah, so since the validation is here, we don't need to do anything here. And we call this generate or broadcast TXCLI function, which will send this message into the app and then into the module, into the handler, and into the keeper. Yeah, the usual path. I think that's it from my side for building the module. I will pass it right now to Anil, and Anil will actually, yeah, run a node and hopefully run these comments like list comment and list post, and to see how you can run your blockchain node and interact with your X block module from the CLI.
Yeah, thanks, Amity.
So I will stop my screen sharing.
I'll share my screen.
I think, yeah, there's Josh who needs to pass to you the rights.
Yeah.
Josh, are you here? Cool. I think I know you need to click on screen share screen below. Yeah, cool. I'll mute myself. I know you're muted, so I probably unmute yourself.
Outside. Okay. So yeah. First I'll start with cloning the repo. I'll just get the link. I'll see. Okay. I don't have any repo now. I'll just use. Okay. So this is done. Step 1 is just a boilerplate, so I'm using step 2. So let's see if this builds. So go. Oh, I need to make a main directory. Go build. Oh, it's taking time.
Yeah, I'll just like to add something like in the step 2 that I know is going right now with activity with anything I built in the previous section in the blog module. So the step 2 is basically the answers of that module.
Let me try again. Why it's. Oops. See if we have anything inside this thing. Not yet. Okay, let's try go install. Oh, this is super fast. So go build will build a build the binary in some specified directory or else go package directory, and if you use go install, it will be it will install the binary in go bin folder. So you can just check which step 2D. Sorry. So yeah, it's inside a bin directory, so you can directly access this with the name. And let's see what are the options we have on step 2D. Yeah, Cobra has some great help documentation style. So it shows all the available commands. So these are all the default commands we have. And then yep, we'll majorly focus on TX and then query. So let's see what's inside TX. Okay, inside TX we have these are default modules from Cosmos SDK or bank and other stuff. Blog is the one which we built just now. So we'll check the transactions there. So blog. Yep. So we have two transactions. One is create comment and one is create post. So let's try to create a post. Create post. Okay. Sorry. So we need to start a chain before this. So to test any of these transactions, let's start a test chain. So step 2D init. That's a blockchain. There is some existing directory for this. I'll just clean up that. Okay, and I'll just create some keys for me. Directory is lace. I'll use keyring backend as tests so that I don't need to process them forever. Okay, I have allies and I'll just create another key. Okay, I have two keys now. So to start a test chain, we need a Genesis transaction, that is to create a validator. So at least we need one validator. So let's create a validator. So to create validator, we need to have funds in one of our accounts. So let's add some accounts before creating validator. Step 2D. Add. I'll just copy the comments from here so that I can save some time. I'll add some tokens to Bob as well. Let's add different stake. Okay, once this is done, we need to create a GenTX transaction, that is to create validator. So I'll just use this. I'll use allies account, and we can pass whatever the amount we want to stake. Let's stake. And from okay, so this created the Genesis transaction. So it will have all the validator information, and then public key and consensus key. And now we just need to collect those GenTXs. So since we are just running a single node chain, so we this one GenTX transaction is enough. If we want to start multiple validators, so we'll collect multiple GenTXs and then keep that in GenTX folder. So and then collect those GenTXs. So if you can see here, it takes GenTXs directory as a flag, defaults to daemon config GenTX directory. You can pass whatever the directory which has GenTX collections. So since we are using just single GenTX and which will be inside this config directory, so I can directly do collect GenTXs. Yeah. So our Genesis should be ready now. So we can start our chain. Awesome. So our chain is up and running. So you can check this chain status here. Status. Yep. Chain is up and latest block is 11. Block height is 11. So yeah, let's execute some transactions, create some posts. Tx blog create post. Let's see what. Okay, so this particular transaction takes two arguments, two parameters, title and body, and then these are all the flags we can supply. So this is my first blog post. That's title and some sample description. And I'll use Ali's account to create this post. I need to supply chain ID, blockchain, and yeah. So since we are using test keyring, so we need to supply the keyring backend option. Yes. Okay, so this is asking for confirmation. Let's confirm. Awesome. So since the code is 0, which means the transaction was successful, we can query the transaction using query tx, and I need to check. Okay, so our transaction is successful, and this is the transaction data. And yeah, if you want to see the response in JSON format, you can just supply -o in JSON. It will show the response in JSON format. Yep. So since we have created a post, let's try to query the post. Step 2D query. So for querying post, we have blog, and blog has two query options. One is list comments and list posts. Let's try to list comment. There are no comments, so we're getting empty response. So let's try to list posts. It should list the post we just created. Okay, so this is the post we just created now. So if there are uh, more posts will get pagination keys. A default page limit is 100. So if there are more than 100 posts, we'll get some pagination stuff. And total represents the total number of pages. Since we just have one single post, there is only one page results, so that's why the number is 1. And then this is the post we just created, so the creator address and then body, and then this is auto generated id per post. So let's try to create a comment for this. tx. Okay, so the create comment is taking two parameters. So one is post id and then body. So I need this post id. I'll just copy it and add some comment. So this is the sample comment, and let's use Bob's account to create comment. And I need to supply keyring option. I'll confirm this. Yep, code status is 0, which means the transaction is successful. I can query this transaction to see the transaction data. Step 2D. Query details. Yep, so this is a transaction data we have, and then this is a message we just submitted. Let's try to query the comments now. Yep, so here is a comment. So which has post ID, and then creator is Bob. Like, step 2D keys show Bob. I need to supply keyring back. Okay, so you can see 4x. Yep. So this is Bob's address, and then we have created a comment for the post. Yep. So this is a CLI. Let's try to check, the REST endpoints. So to enable REST, we need to enable it in the config. So I'll just try to edit the config file. Log app. App.com. So yep. So here we have the configuration related to API. So I'll just enable this true, and I'll enable Swagger as well. Okay. So I need to restart the node to me for those changes. I'll just stop it and start it back. So yeah, it started. So this is the REST endpoint. So let's see, blog list post. Let's go back to the code. What is our query endpoint? List.
I think it should be slash like rest.
Sorry, can you repeat? Your voice is.
Yeah, in the GitHub, we'll go to rest. In the wait, sorry, custom. Yeah, here rest. Um, no, not here. In the slash x blog client rest.com.
Let's see, Swagger docs. So, this is not added automatically. So, Amri, can you share that?
Yeah, sure. Here in the chat box. In the chat and the email. You see the screen here? Can you go to the screen now? No, I can't hear you. No, yeah. I'll say this in this way. Okay.
Oh, no, sorry, my screenshot dropped. I think there is no custom. No, I think custom is just the key for this.
Okay.
Yeah. This is strange.
Yeah, true. Well, anyways, we can move on.
Yeah. Anyways, so yep. We'll share the documentation on this. We'll update the GitHub repo, and yep. So That's it pretty much on interacting with the chain. So we just created a chain and then walk you through how to create posts and comments and then list posts and comments. So you can just extend it to get single post and then get single comment. Yep. So anything we are missing, Amari?
I think not. Can you just show the slides, Google Slides? I just want to add something about the libraries that you can use on the client side.
Okay, I'll just share that.
Yeah, I think it's at the end.
Okay.
Yeah, exactly. So yeah, so in this in the live demo, I knew showed about the CLI and the REST endpoints within work, which we should look into. But anyways, there are other ways to query the state and to send transactions. So we discussed to query the states. We have gRPC. The gRPC client could also be a good way. Like right now, there's no really gRPC clients that are Cosmos specific that are built, except for one, which is Cosmos.js. I think there was one workshop with Cosmos.js. I don't know the status about how they're updated to Stargate and how ready it is. But yeah, it should be cool. So the Cosmos.js, it's a full package. You can query the state using the gRPC one, and you can also sign transactions and generate transactions. So it's like a full package. That's what I wrote here. But for if you only want to do state querying, to be honest, like any gRPC client should do. So a gRPC client is really like, yeah, you just given the proto files from the service, from the query services that's defined in the proto files, it can know which endpoints are available, so which endpoints to query, with which kind of arguments to put into. So yeah, any gRPC clients should do, and there are gRPC clients in a lot of languages. So the state querying part should be actually quite easy. We wanted to show a gRPC example, like example with gRPC curl, but I don't think like it's maybe not worth it in this workshop because it's really a niche and used for debugging mostly. But anyways, I just wanted to put it here that it's available. So if you look for gRPC clients in any language, you'll find a lot. And if you input those curl files, it should be able to do all the magic behind the scenes. Yeah, I guess that's all what I wanted to add. I know you can go to the next slide. Yeah, so I guess that's it for the workshop. If you have questions, please feel free to ask them in the chat. We can answer them right now. So if you want to contact us, here's the emails on this last slide. And yeah, and if you want to see the slides, they're also online so that you can have a look after the workshop, or if you're watching a replay of this YouTube video. Cool then. Thanks everyone. We'll stay here 5 minutes. If we see questions, then we'll stay a bit more. If not, then thanks everyone.
Okay, looks like there are no questions. So,
Cool then.
yep, thanks everyone.
Thanks. Bye bye everyone.
Bye bye.